Okay, so 5 is multiple and product of sum formulas, but actually that's what it's called. There's two other things in this section, which is what we're going to actually cover. We're not going to talk about multiple and product of sum. We're going to talk about the double angle and the half angle formulas. So the first one is the double angle formulas, okay? And basically the idea is this. If you had an angle, like say 15 degrees, and I wanted you to find the sine or the cosine or the tangent of it, right? You don't know that because it's not a unit circle based angle. But if it's one of the angles that if I double it, it is unit circle based, then I use these formulas. So I would double it and I would figure it out. That's kind of the idea between a double angle, and then a half angle is the other way around. So if I had a value in which it wasn't on my unit circle, but if I cut it in half it is, then I use the half angle formulas. And then we'll also use these with triangles. You will be given these formulas on your test. So every formula that you see today, I will provide for you on your midterm, okay? I'll also provide for you a unit circle. So you get a unit circle and you'll get the double angle and the half angle formulas. So the double angle for sine is 2 sine u cosine u. U represents the angle. Cosine 2u has 3 options. Cosine squared u minus sine squared u, or if you think about replacing these with the identities that they work with, like if I take sine and replace it with 1 minus cosine squared u, then I get cosine squared u minus 1 plus cosine squared u, which gives you 2 cosine u minus 1. So this is just an alternative for the first one. And we'll talk about why you would choose one over the other in a little bit. And then if I were to replace cosine with 1 minus sine squared u and distribute, or just get rid of the parentheses really, and then combine my 2 negative sine squared u's, I'd end up with 1 minus 2 sine squared u. So that's another option. And these are interchangeable. You can use any of those 3. If you only had the cosine, obviously you would use the second one. If you only had the sine, you would use the third one. If you had the cosine and the sine, you would use the first one because it would already have a like denominator. And then tangent to u is 2 tan u over 1 minus tan squared u. Again, these formulas will be given to you, but the more you practice them, the easier it's going to be to recall them. All right, so this first question is triangle based, and I know that because there's no such thing as 3/5 on my unit circle, right? So this says find the exact values of sine 2u, cosine 2u, and tangent 2u. If you're given tangent of u is 3/5, and u lies between 0 and pi over 2. So I start with my triangle. I put u in the corner. Tangent is opposite over hypotenuse. Is my missing side 4? No, why not? There's a triple 3, 4, 5, but that 5 would have had to been on the hypotenuse, right? So I'm going to find the missing side by doing 3 squared plus 5 squared. 9 plus 25, which is 34. Square root of 34 is my hypotenuse. Now this piece of information, the in between 0 and pi over 2, tells you that it's located where? First quadrant, which means what? All of them are positive. So the reason you need that information is because you need to know to make the missing side positive or negative because it's in the first quadrant, everything's positive. With me so far? Okay, so now I'm going to start with sine of 2u. And I just screenshot and pulled it in over here. But there's my equation, which is 2 sine u cosine u. So I do 2 times the sine of this triangle, which is 3 over root 34, times cosine, which is 5 over root 34. Now, normally I would rationalize those fractions, but because we're going to multiply root 34 times root 34, I can save myself the hassle of rationalizing them because I'm just going to get rid of it anyways. So I can multiply straight out on my numerators. I get 2 times 3, which is 6. Times 5, which is 6 times 5, which is 30, over the square root of 34, square root of 34, 34, and that gets reduced to 15 over 17. Is it not working? All right, then I would go to cosine of 2u. And you have options. I can either do cosine minus 1, or 1 minus sine. And you could choose. It doesn't really matter. The benefit of choosing cosine and sine is that it will already have the same denominator. Whereas the other one, you'd have to change 1 to be the denominator. They're probably just as easy. Okay? but I tend to pick the cosine and sine just because it already will have the same denominator. So this is cosine squared u minus sine squared u. Cosine is 5 over root 34 squared minus sine 3 over root 34 squared. And then I'd get 25 over 34 minus 9 over 34. And I get 16 over 34, or 8 over 17. Questions on those so far? Okay, then comes tangent. So what could we do for tangent?
Put the sine over the
I could actually put the sine over the cosine. So tangent 2u is the same thing as saying sine 2u over cosine 2u. Now, just like your sum and difference, I'm not going to ask you for all 3 parts of these on your test. So I would say make sure you also know how to go straight there using the tangent equation, which is 2 tan u over 1 minus tan squared u. So 2 times 3/5 over 1 minus 3/5 squared. And I get 6/5 over, this would be 9/25, and this is 25 over 25. So 16/25. And then keep change flip. 5 goes into 25 5 times. 6 and 16 are both divisible by 2. And I get 3 times 5 or 18 over 8. And again, if I had already gotten sine and cosine, it should be the same answer by putting the sine over the cosine. So 15 over 17 over 8 over 17. Keep change flip. And I get 15 over 8. But again, midterm, like homework, that's fine because you're going to get all 3 on one question. So if you want to do both, that's fine. But on the midterm, you will only get one of those 3. You're not going to get all 3. So you make sure you know how to do it by plugging in the equation as well. Questions on that one? So that's double angle, triangle based. Ian?
On the top, why is it 6 over 8? Just multiply 2 to the next 3 over 5.
On the top, what color? What color are you talking about?
Purple on the bottom.
Purple here. Oh, I did 2 times 3/5. That's not an 8, that's a 5. I just crossed through it so it looks like an 8. All right, then you'll see them kind of in your solving equations. You can see it in the verifying, kind of like what we did with the sum and difference. This says find the exact solution of the equation in the interval of 0 to 2 pi. Yours is missing the bracket and the parentheses if you want to add that on. So if you think about what we did with the initial equation, if it was squared, we would have factored it. If we had a sum or difference, we would have expanded it in the sum or difference. Now it's a double angle, right? So cosine 2x is going to get replaced with any of these 3. Now the first one has sine and cosine. If I introduce another trig function, and am I going to be able to solve that? No. So I don't want to pick the first one, and I don't want to pick the third one. I don't want to have a sine and a cosine. I'm going to pick the second one because it's only cosine. So cosine of 2x is going to get replaced with 2 cosine squared of x minus 1 minus the cosine x that's there equals 0. Now, what should happen in your brain is as soon as you see a squared and a non-squared, you should know you're going to have to factor this. So I'm going to get it in order so that I can factor it, decreasing degree order. And then I'm going to factor it. Factor of 2 cosine squared is 2 cosine and cosine. Factors of -1 would be 1's positive, 1's negative. I got to figure out what's going to give me a negative in the inside. So a positive 1 here and a negative 1 here is a -2 plus 1, and there's my -1, so that's the combination that works. Then you set them each equal to 0, and I get 2 cosine x plus 1 equals 0, and cosine x minus 1 equals 0. 2 cosine x would equal -1, and cosine x would equal negative 1/2. Cosine x here would equal 1. So now it gave me the interval this time. I want to use my standard unit circle. Nope, not the blank one. To find the values in which, or to find the angles, in which cosine is negative 1/2, which is happening here and here, and also positive 1, which is happening here. So my answers would be 0, 2 pi over 3, and 4 pi over 3. Questions on that one? So you're bringing the double angle now into the solving. Let me show you what's happening on quizzes and tests that needs to stop because it doesn't work. People are doing this. Bumping the 1 to the other side, taking out the cosine, and then splitting them and setting them each equal to 1. What's wrong with that?
Just because 1 equals 1, the other one could equal something else.
Exactly. So just because this part equals 1 does not mean my whole equation would end up being 1, right? So if I say this is 1 and I have 1 times a number, right? It could be 3. Does that equal 1? No, right? The only way this works is if it's equal to 0. Because if one of two factors that are being multiplied together is 0, the entire thing is 0, right? That's why we could do this. The only way you can do that is if your equation equals 0. So I saw, like, not necessarily from this group, throughout the day a couple of times, all sorts of that happening. Bumping numbers to the other side of the equation and then splitting and solving. It only works if it's equal to 0. It's the 0 property of multiplication. If one of the factors you're multiplying by is 0, the entire product is 0 no matter what it is. That doesn't work with any other number. So be really careful with that, because obviously that affects now, but that affects like every equation you've ever solved that is quadratic or higher. You can't split things and set them equal to something other than 0. You always have to get a set equal to 0. Does that make sense? For those of you that, I don't know if those people that do that are actually listening to me right now, but you want to be, because it's something that can't continue, ever. All right, this says use the double angle formula to rewrite the expression. So there is now we're working the other way around, okay? This is already the expression, and you want to figure out which one it is. So if I look at the patterns that I'm given, and I pulled them in on the top over here, which of these has the product of the sine and the cosine? Sine of 2u, right? Or sine of 2u, right? That's the one that's got the product. But it is 2 times sine u cosine u. So how do I rewrite 6 that the 2 would get separated off? This would be 3 times 2 sine x cosine x. And then 2 sine x cosine x is the same thing as sine 2x. So this time you're flipping it around the other way. It's already giving it to you in the double angle formula, and you're rewriting as its original. And that's as far as you need to take it. So if in that equation I had a cosine squared and a sine squared, then I'd be using cosine 2u. If I had tangents, obviously I'd be using tangents. Questions on that one? 2 slides and go to half angle. So half angle is the other way around, okay? This time you'll get something that is not on your unit circle, God bless you, but if you doubled it, it would be on your unit circle. So if I had like 15 degrees, okay, obviously I'm not going to be able to find it because that's not unit circle based, but if I double it and plug it into these formulas, it will give you your equation. This time, notice that these say plus and minus for sine and cosine. So I have to plug it into the formula, 1 minus cosine u over 2 underneath the square root. And then based on the original location of my original angle is how you choose plus or minus. So this says it down here. It's the quadrant that u over 2 lies, which means the original angle. So if I'm trying to find the cosine of 15 degrees, I'm going to double it to plug it in here. But when I go to find the positive or negative, I come back to 15 degrees, and 15 degrees cosine would have what sign? Positive, so I would pick positive, okay? Let's say I did 100, okay? Cosine of 100. This doesn't work for unit circle base, but this is just an example. I would double it to plug it in here, so it'd be 200. So I'd be doing this off the base of 200, which is in my third quadrant. But when I go to pick positive or negative, I go back to where it's 100, which is second quadrant, and the cosine there's negative. So when you're determining the plus and minus, you always go back to the original angle. Tangent, you don't have to worry about it because tangent works itself out. You use the cosine and the sine, so it figures itself out. But sine and cosine, you got to pay attention to where the original angle would be, and that's how you pick the plus or minus. All right, so this says, wait for it, use the half angle formulas to determine the exact values of the sine, cosine, and tangent of the angle. Okay, so I again brought in these formulas. This would be the second set of formulas that you're given. These are the half angle ones, okay? I'm going to say use the exact values to find all three, sine, cosine, and tangent. So we're going to do all three this time. Obviously, test-wise, it would be 1. You're not going to get asked all three. So the first thing I want to find is the sine of 75 over 2, because that's what, or sorry, not exact 75, sine of 75, which would be the same thing as 150 over 2. So when I use the angle in the equation, it's always going to be the doubled one. But when I look at the answer, I have to go back to the original to find the plus or minus. So where is 75 located? 75 degrees. What quadrant? Quadrant 1, which means the sign there is going to be what? Positive. So my advice is pick it from the beginning and make sure you know it, so you don't forget, because a lot of times people forget to go back and check the plus or minus. Okay, so then I'm going to say that this is the square root of 1 minus cosine of my doubled angle, 150, over 2. So then if you think about your unit circle, 150 is here. This is negative root 3 over 2 and 1/2. So the cosine is negative root 3 over 2. So this becomes plus 1 becomes 2 over 2. I get the square root of 2 plus root 3 all over 2 over the 2 that's part of my original equation. Now I've got a fraction within a fraction, so I'm going to do what? Keep, change, flip. This becomes times 1/2. And I get the square root of 2 plus root 3 over 2 times 2, which is 4. And then I split that square root. So this is the square root of 2 plus root 3 over 2. And from the beginning we said it's positive, so it stays this way. Oops. Yes. Okay. Now think about what would have happened if we had done the sum or difference on this. Okay, we could have broken 75 down. I don't know if that was one of your questions yesterday. Did you guys have 75? Somebody did yesterday. I don't know if it was your group.
We had a bigger number.
Okay, you could have broken it down in 30 and 45, right? And the answer of this would have resulted in 2 plus root 3 over 4. Oh, no, it would have been root 6. Root 2 plus root 6 over 4. Okay? Which is the same thing you would get if you squared everything in here. So if it said sum and difference, or if it said half angle, it should get you the same answer because sine of 75 is sine of 75. If you plugged this into your calculator, square root of 2 plus root 3 over 2, you should get the same answer as if you hit sine of 75. It's always going to be the same. It's not like it changes for the value.
So, is the square root of 6?
The square of the square root. You'd have to square it all to get rid of the square root underneath this. So that is a fourth root is what is happening, right? Because you're square rooting a square root, so it's a half. That's a fourth root, and the fourth root squared doubles it.
Okay.
Does that make sense? Okay. I'm not going to make you do that. You can keep it under the root. But if you were to compare answers, that's how you would have to do it. When you square root a square root, you are actually taking the fourth root of the number. Okay, so now that was sine, right? So now we're going to do cosine. Cosine of 75. And this one is 1 plus cosine over 2. Now the positive or negative, again, we choose. If 75 is in my first quadrant, what is the sign of cosine? Positive again. And then it's the square root of 1 plus cosine of 150 over 2. We already found the cosine at 150. It's negative root 3 over 2. So I get the square root of 1 minus root 3 over 2 over 2. Change this to be 2 over 2. And I get the square root of 2 minus root 3 over 2 all over 2. Change, flip. I get the square root of 2 minus root 3 over 4. Split it. Stays positive. Okay, and then last one is tangent. So tangent of 75. Go back to your tangent, which is 2 tangent. Or sorry, it's 1 minus cosine over sine, or sine over 1 plus cosine, and it doesn't matter which one you pick. So I'm just going to pick the first one. 1 minus cosine 150 over the sine of 150. So 1 minus a negative root 3 over 2 over a positive 1/2, because that's what the sign is there. Come on, you would do it. All right, so then this becomes 2 over 2. This becomes plus, and I get 2 plus root 3. This is 2 over 2 over 1/2. Change, flip. And I get 2 plus root 3. So I think the tangents of the half angles are easier than a sum and difference, because you're not doing like the, I don't know if you remember from yesterday, but you had to like do the rationalizing at the end. This eliminates it. So if you already had sine and cosine, you could do keep, change, flip on the sine and the cosine to get tangent. But again, test based, you'll only get one of these. So you want to make sure you know how to get there directly. Questions on that one? Okay, so B says 5 pi over 12. Again, an angle that's not unit circle base, but what happens when I double it? What do I get? Two goes into 12. 6 times. I get 5 pi over 6. Is 5 pi over 6 on my unit circle? Yeah, so this is my U. But when I figure out plus and minus, I go back to 5 pi over 12. So in order for these to work, obviously the angle that's initially given to you will not be on your unit circle, but the double angled will be. That's the only way these work. Okay, so it's not like I can give you any angle. It has to be an angle that's on my unit circle halved. Okay. And again, test-wise, it will ask you for just a specific one. I think the homework for this one does the same thing, give you sine, cosine, tangent, do all three. Test-wise, it would just ask for an individual one. Okay, so I'm coming back up here to this answer, because if you do it on WebAssign like that, it's fine. If it was an open-ended question, it would be fine. But on a multiple choice test, which this question on your midterm is multiple choice, it's going to pull out the 1/2. So it says 1/2 square root 2 plus root 3. This is the format it would be on the multiple choice test. Okay. Just like the double angles, we do the half angles with the triangles as well. Okay, same initial setup. It says that the tangent is going to be given to you, the location of that angle is going to be given to you, and then you plug it into your formulas. So determine the quadrant in which U2 lies, and this is important because obviously you need to know if it's positive or negative. Find the exact values of sine U2, cosine U over 2, and tangent U over 2. Now notice that it's giving you the tangent of U, but it wants the quadrant of U over 2 because that's what we're eventually finding. So if U lies between 3 pi over 2 and 2 pi, where is 3? Where is U?
The fourth.
It's in the fourth quadrant, right? So if you took any angle in the fourth quadrant and you cut it in half, where do you think it's going to go?
The second.
Second quadrant. Any angle. So if I take 300, cut it in half, it's 150. I take, 330, cut it in half, right? Everything goes to the second quadrant. So this is where it gets tricky because that one makes sense, right? But if I take an angle in the third quadrant and cut it in half, where do you think it goes? What's an angle that's easy, that's even in the third quadrant? 200, yeah. Take 200, cut it in half, where's it go?
100.
Which is what quadrant?
Second.
Second quadrant. Take 220, cut it in half, what is it? 110, second quadrant. So third quadrant also cut in half goes to second quadrant. So if it's in quadrant 4, if whatever the angle is in quadrant 4, then U over 2 is in quadrant 2. If U is in quadrant 3, then U over 2 is in quadrant 2. And then what do you think happens to things that are in quadrant 2 if I cut them in half? Pick an angle in quadrant 2. That's easy and even. 100 cut it in half? 50, where's that? Quadrant 1. All angles in quadrant 2, when cut in half, go to quadrant 1. What do you think is going to happen to the angles in quadrant 1? What happens if I take 60 and divide it by 2? It becomes smaller, but it's never become negative, right? Quadrant 1 stays in quadrant 1. So all of that's important so that you know what sign to put on the answer if it's sine and cosine. So if my initial angle, which is U, is in the fourth quadrant, then U over 2 is in quadrant 2. Which means my cosine is going to be negative and my sine is going to be positive. Now I got to set up my triangle. So tangent of U is 5 over 12. One of these is negative. If it's in the fourth quadrant, which one? The 5, right? The y is going to be negative. The x moves forward, but the y goes down, right? What's the missing side here? 13. This is a triple. So now the sine of U over 2, which we said is going to be positive, square root of 1 minus cosine of U over 2, which is 1 minus 12 over 13 over 2, all that's underneath the square root. This becomes 13 over 13 13 minus 12 over 13 over 2, 1 over 13 over 2, keep change flip, square root of 1 over 26, which becomes square root 1 over square root 26, 1 over root 26, or root 26 over 26. And we said, because u over 2 would be in the second quadrant, my sign is positive. Now I repeat that whole process for cosine, but we said cosine in the second quadrant is going to be negative. So I put a negative in the front. Square root of 1 plus cosine of u over 2. 1 plus 12 over 13 over 2. 13 over 13 plus 12 over 13. 25 over 13 over 2. Keep change flip. Square root of 25 over 26. Square root 25 over square root 26. 5 over root 26, which becomes 5 root 26 over 26. But it's negative because we said the cosine at this halved angle would be negative because it's in the second quadrant. And then the last one is tangent. And remember, tangent, it doesn't matter the sign. There's no plus or minus in front of this. And you can pick either one. So I can do 1 minus cosine over sine, or I can do sine over 1 plus cosine. So 1 minus the cosine of this triangle, which is 12 over 13, over the sine, which is negative 5 over 13. This becomes 13 over 13. 1 over 13 over negative 5 over 13. Keep change flip. And I get negative 1/5, which I also would have gotten if I had put sine over cosine. But again, test-wise, you won't get directly, you'll only get directly one of these, not all three parts. Questions? So both types of formulas use triangles, the u over 2 or the 2u. Okay, you got to pay attention to what it wants. If it says find sine of 2, you're using the double angles. If it says sine of u over 2, you're using the half angles. And then we did the half angle one with just the angles. Those are the only ones, the double angles you saw like in your equations and that kind of stuff.